Good day. All right, we're going to work on example 7-4, and this is still from chapter 7, section 1, talking about confidence intervals. In this one, the theme is automobile thefts. It says a sociologist wishes to estimate the average number of automobile thefts in a large city per day within two automobiles. He wishes to be 99% confident, and from a previous study, the standard deviation was found to be 4.2. How many days should he select to survey? Okay, all right. So here, the one thing to note is the verbiage that it gave us in this hypothetical problem is he found from a previous study the standard deviation. And so even though that is not for this current study, we're making an assumption. So this is an estimate most of the time, like I said. If we don't have the population mean, then there's probably no way we have the population standard deviation. Anyhow, he wishes to be 99% confident. 1 minus alpha equals 0.99. That means alpha equals 0.01. So the z subscript alpha over 2, we just looked this one up. It's not our favorite one, but it's one of them. Okay. And then the margin of error. So we wanted it to be accurate within two automobiles. So that's our plus or minus 2. Okay. And then what we're trying to do here is we're trying to find n. And the other types of problems we've been given n, we've been trying to find our margin of error so we can create the confidence interval. But here we don't have n. We know the margin of error. We know the size that we want to make our confidence interval. We just need to know how big to increase our sample size up to so that we'll be able to have that that level of specificity, or that margin of error. Okay, so let's go ahead and do that. The margin of error and the sample size are related. We saw that we have a formula that relates, well, the formula that we have that defines the margin of error, we can basically just take that and algebraically rearrange it, and instead of solve it for E is going to be in here, and we'll isolate n. So this formula rearranged becomes z subscript alpha over 2 times sigma, it's a little bit messy to read here, all of that divided by whatever the margin of error is, and then that whole thing, let's extend these parentheses a little bit more, that whole thing is going to be squared. Okay, so we won't go into the derivation of that, won't go into how we got that, but other than I'll say that that's just isolating n out of our original formula for the margin of error. Okay, so here all we're going to do is plug in everything. Notice that alpha doesn't actually go into this formula. It was what we used to find this z subscript alpha over 2. So we'll go ahead and plug in everything. We have 2.58 in place of the critical z subscript alpha over 2. For sigma, we're putting in 4.2, like such. For E, we have, oh, I was going to write E. Let's not do that. Let's write 2 instead. And then all of that business, the whole thing is going to get squared. All right, so allow me to go ahead and catch up with this calculation. Okay, so got out 29.35, which normally we would just round it to 29.4. But here, since we're talking about a sample size, we don't want, 0.4 in this case, days, right, to sample. Um, we want our sample number to be usually a whole number, usually an integer. So here it's saying that we need to sample at least 30 days in order to get this level of accuracy. If we know the standard deviation and we have our confidence level that we need, we've found the sample size that would generate that degree of accuracy. Okay, so we'll end this example.